If you've ever looked closely at a U.S. Navy warship, you've probably seen it. The small white turret with a spinning radar dome perched near the deck, staring out over the sea like a watchful sentry. That's the Phalanx Close-In Weapon System, CIWS, the Navy's last line of defense and one of the most recognizable features on its ships. From aircraft carriers to destroyers and amphibious assault vessels, nearly every major American warship carries at least one. Its rapid-fire cannon and self-contained radar make it the U.S. Navy's guardian angel, always scanning, always ready, and always the final word when danger closes in. The Phalanx is the last defensive shield for many naval ships. It is designed to protect against missiles, aircraft, drones, and small, fast-moving surface threats. Its mission is simple but crucial. Stop any incoming danger that slips through outer layers of defense before it can strike the ship. In this video, Defense Updates analyzes what makes Phalanx CIWS so important for U.S. military. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Phalanx is a self-contained weapon system. It carries its own radar, sensors, gun, and ammunition supply in a single mount. This makes it independent from the ship's main fire control network. Once switched on, it can detect, track, and fire automatically without outside direction. At the heart of the Phalanx is a 20mm M61A1 Vulcan Gatling gun. The weapon has 6 barrels that rotate rapidly to achieve an extremely high rate of fire, often above 4,000 rounds per minute. The ammunition consists of dense armor-piercing projectiles made from tungsten or depleted uranium. Each round is designed to tear through the thin skin of incoming missiles or shred their control systems before they reach the ship. The gun and radar are mounted together in a compact white turret. The radar antennas sit inside the distinctive dome at the top, giving Phalanx its familiar R2-D2 appearance seen on warships worldwide. The ammunition is stored in a drum beneath the gun and is fed into the barrels through a flexible belt system. This design allows sustained bursts when a threat is detected. The system uses Ku-band radar for both searching and tracking, giving it accurate readings even on small, fast targets. Later versions added electro-optical and infrared sensors, providing another way to detect and aim when radar performance is affected by clutter or electronic interference. The mount can rotate quickly and change elevation to track targets approaching from different directions. The ammunition drum usually holds more than 1,500 rounds, giving the system enough firepower to handle several engagements before needing to reload. Phalanx operates in 3 main stages: detection, tracking, and engagement. The radar continuously scans the surrounding air and sea for objects moving at high speed and low altitude. When it detects a possible threat, the system automatically locks on and begins tracking its position, speed, and direction. The onboard computer then calculates where the target will be within seconds and aims the gun accordingly. Once the target enters the engagement zone, the Phalanx opens fire with rapid bursts, creating a dense wall of projectiles. If the crew enables automatic mode, the system can do all of this without a manual command to fire. This level of speed and automation is essential for intercepting sea-skimming missiles that leave almost no reaction time. The system also provides defense against small, fast boats, helicopters, and drones, especially in coastal waters where conventional air defenses are less effective. Because it is self-contained and relatively compact, it can be installed on almost any decent-sized warships. For many ships, especially smaller ones, Phalanx is the main self-defense weapon and a psychological assurance that the vessel has a backup when everything else fails. The Phalanx was first introduced in the early 1980s after years of development by General Dynamics and later production by Raytheon. Since entering service, it has gone through several major upgrade stages, known as block improvements. The original Block 0 model provided the base capability of automatic radar-guided fire. Block 1 increased the rate of fire and expanded the ammunition capacity. The following Block 1A introduced improved radar tracking and updated computer systems, allowing faster and more accurate targeting. The Block 1B added a forward-looking infrared FLIR camera and new control modes that let the weapon engage slow air targets and small surface boats, not just missiles. The most recent baseline versions include digital control systems, improved radar reliability, and faster signal processing. Each new version improved the Phalanx ability to deal with evolving threats, such as stealthier and faster anti-ship weapons. Although it was designed for ships, Phalanx has also been adapted for land use. A modified version called CRAM, short for Counter-Rocket, Artillery, and Mortar, protects ground installations from short-range attacks. It uses the same gun and radar system but fires special ammunition designed for use over populated areas. This version has been used by the U.S. Army and allied forces to defend forward bases and critical infrastructure. Phalanx offers several strengths that explain its long service life. It operates automatically, allowing instant reactions to surprise attacks. It is compact, easy to install, and self-contained, requiring only power and minimal integration with the ship's systems. It reacts in seconds, faster than any human-controlled gun could. Its performance has been proven over decades of tests, training, and real-world use. The combination of radar and optical sensors gives it high accuracy, and its rate of fire creates a near-impenetrable barrier at close range. Phalanx is used by many allied navies around the world. Countries such as Australia, Canada, Japan, South Korea, the United Kingdom, Saudi Arabia, Greece, and others deploy it on their ships. Raytheon continues to supply modernization kits and service packages that extend the weapon's operational life. The U.S. Navy continues to invest in upgrades for the Phalanx CIWS. Current work focuses on digital control, improved radar detection, and faster computer processing. Some programs explore smarter ammunition and advanced tracking algorithms. Future developments may include directed energy weapons, such as shipboard lasers. But for now, the Phalanx remains the most proven and available close-in defense system. Its design continues to evolve, ensuring it can handle both traditional missile threats and modern drones or swarm attacks. Strategically, Phalanx remains a vital part of naval defense. It guards high-value ships such as aircraft carriers and logistics vessels, allowing fleets to operate safely in contested areas. The presence of Phalanx on a ship adds confidence to commanders and crews. Its long history, global use, and continued modernization make it one of the most recognizable and reliable defensive systems at sea. From its Cold War origins to its modern digital upgrades, it has proven adaptable and durable. Phalanx remains the benchmark for close-range ship protection, a dependable guardian for fleets across the world.